Hello everyone, welcome to another calculus video. In this video I'm going to be showing you some notation for how we would represent derivatives mathematically. I hope you either watched my previous video on taking basic derivatives or you already know how to take derivatives. And today I'll show you how to represent derivatives mathematically. In my last video I wrote out the word derivative to show what the derivative was, but we would not typically do that. Instead, we would express the derivative mathematically based on how a function is introduced to us. So in our first example, y equals 7x, we're given a function with a value for y. So to express that derivative, we would write y prime, which is y with a little mark over it. And the prime part signifies that we're dealing with the derivative. And we know that the derivative of 7x is 7 because that's the slope of the function. So we have y prime equals 7. And if we were to graph that, that would be a straight horizontal line at the point y equals 7. And what that tells us is that at any point, the derivative of the graph y equals 7x will equal 7. So now similarly, let's look at our next example, f of x equals 7x. This is just another way to write y equals 7x. The f of x part specifies that this is a function where for every input of x, our output of x will be 7 times our initial input. So if we were to write the derivative of that, we would do something very similar. We would write f prime of x, a little dash right above the x. And that derivative would also be 7 because it's the same function. And what f prime of x tells us is that for every input of x, the derivative at that point would be 7. And that makes sense because for a linear function, the slope will always remain constant, so the derivative remains constant as well. Now what we might sometimes see is that we're not given an actual equation. There's no equal sign, we're only given a function like 7x. And we might have to take the derivative of that, assuming that it's meant to represent a function. So one way we can do that is we can represent that as dy divided by dx. And dy divided by dx, you can think of that as being the difference in y divided by the difference in x, or the change in y divided by change in x. And change in y divided by change in x equals the slope, and in turn the slope equals the derivative. And you can also think about that as something as rise over run, or y2 minus y1 divided by x2 minus x1. Those are all formulas for finding the slope or derivative. So by writing dy by dx equals 7, we're signifying that at any point the change in y divided by the change in x will be 7 for this graph. And one final way to express derivatives, or one final example for this video, is similar to our last one. This will be d divided by dx, and this is very similar to dy by dx, but this is more of an operation. So we might see it in this form, where d by dx is basically telling us to take the derivative. And taking the derivative, we would get 7 once again. So these 4 examples are 4 common ways to represent the first derivative of a function. We can also take the second derivative of functions. And what that means is we're just going to take the derivative of the derivative that we already had. And the notation for that will be pretty similar to the notation for the first derivative. So I'll go ahead and introduce that as well in this video. For the second derivative of y, we can write that as y double prime, which is 2 little dashes over the y. And if we take the derivative the derivative of 7 is 0, because that is a constant term. That's like saying 0x plus 7, and in that case the slope would be 7. So since we know the second derivative, I'll go ahead and just focus on the notation for now. For f prime of x, the derivative of that would be f double prime of x, and that still equals 0. The two dashes signify we're taking the second derivative of the original function. For dy by dx, we would write the second derivative as d2y divided by dx squared. The 2's symbolize second derivative. That would be 0. And if we had to take the second derivative of something and we needed an operation for that, we could write that as d2 over dx squared over original function, and that would be 0 as well. So these are all ways to write the first and second derivatives of functions. We could have notation for third derivatives and fourth derivatives and so on as well. It would follow the same pattern. But I hope that by watching this video you are now more familiar with how we might express derivatives mathematically.